because on a pin, this is Danae, right?
Yeah.
On a pin Danae, and I'm like, sorry.
Okay, we are going to move forward into the next section. Now, obviously, guys, everybody else is hitting a test before they get to Thanksgiving. You guys just had a test, so you're in good shape.
Oh my
We're just
goodness.
doing good stuff, but then that means you have to remember the stuff.
Oh.
All right, proportions and ratios. If I asked you the ratio of males to females in your family, Rebecca, what's the ratio of males to females?
3 to 2.
Okay. So basically, I'm just counting up the number of males and the number of females. And a ratio is just a fraction.
My family's like
Okay.
that too.
It can be written like this. It can be written like this. But most often it's written as a fraction because you're going to use it math-wise. If you have two ratios together, you have what's called a proportion. So let's say we doubled the amount of females in Rebecca's household. How many males would we have to keep the same ratio?
4,
Okay, what do I have to do to multiply to get to this?
2.
2. So I would multiply the top by 2 as well, so that's going to give me a 6/4. Okay, now there's another way to do this. This is all algebra 2 stuff. Hopefully you remember this. Okay, remember cross products? Okay?
Yeah.
Alright, so 2x is equal to 12. When I divide by 2, I get a 6. So I know that on the top would have been a 6. Because you can't always turn around and look and go, what can I multiply to get that? What if I had a 5 there? Okay, I couldn't multiply anything easily to get that 5. So sometimes you have to do it a different way. If you put two ratios together, let's say I have 2 11ths and 4 15ths. And I go, wonder if these are equal. Well, I could reduce them all down to decimals and divide the top by the bottom and get a decimal value. Or I can cross product and go 15 times 2 is 30, 11 times 4 is 44. They're not equal. Okay, you can also do inequalities that way, because if I'm multiplying from the bottom up, which one of those is bigger?
24.
Therefore, I know that fraction is bigger. It works every time. Okay, that's not really in this chapter, but just in case you forgot it, there it is for nothing. You have positions here. I'm going to do one that actually is equal. Let's say I have... Alright, I know that those two ratios are equal. That's a proportion. I have positions in here, and I think we did something like this in algebra, but I'm not sure how deeply we got into it. Okay, those two positions, here and here, are called the means. These two positions out here are called the extremes. Okay, if you were doing dun, 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 the first and the last are your extremes. Should make sense to you. The ones in the middle are called your means. Okay, or kind of like the averages, if you will. Let me give you a couple of these. I mean, I think all this stuff is just review right here, and then we're going to take them and we're going to apply it to triangles. I want you to solve this proportion for me. And I want you to solve this proportion for me. decimal or fraction? Well, they should have both come out whole. So.
They're both whole, so that's a good sign.
Did you get it?
Yeah.
Careless mistake? I say always in math,
So frustrating.
most of the time. Okay, you should have got a 45 on the top one and a -7 on the bottom one. Is that what you got? Okay, now, I don't anticipate any problems with any, you're gonna have some like this, okay? You're gonna quickly do them. You did an algebra 1, you conquered it, no problem. This is often used in word problems, okay? We did word problems in algebra 1 and algebra 2, okay? So hopefully you can do that, you can set them up. These are the problems where we wrote categories, like we wrote a top and a bottom category, if you remember right. We did it like with maps, with keys on maps, like 1 inch equals 3 miles. And we might have put inches on the top, miles on the bottom.
Was this
We did it, do what?
I don't think
I know you did it. That's the disadvantage to, I know you did it.
I did it, but I don't.
You don't remember it.
I don't remember. Did I do this with you?
Yeah.
I did this with you.
Yeah,
Really?
yeah.
I don't remember.
Okay, here's an example problem. A twin jet airplane has a length of 78 meters and a wingspan of 90 meters. A toy model is made in proportion to the real airplane. If the wingspan of the toy is 36 centimeters, find the length of the toy. So basically this is what I have. I have two things, and I can do it a couple different ways. I'm going to do it, I'll show you both ways, okay? I have the length, and I have the wingspan, and I have the toy, and I have the actual. Now, if I go through and read this again, it says a twin jet airplane has a length of 78 meters. So I put the length on the top. It's under actual. Okay, I'm setting up a proportion. Okay, a wingspan of 90 meters. Okay, because I put the length over the wingspan. Then I'm over here to the toy, and it says the toy has a wingspan of 36. So where's that going to go? If it's on the bottom, because I already put that. Was it centimeters? What was it? Yeah, centimeters. It wants to know the length. All I do
It's cross multiply.
is cross multiply.
But you can't really multiply things that are meters for millimeters.
So I've got 90x is equal to 36 times 78. 2,808. How am I going to solve for the x?
You're gonna divide.
I'm going to divide by 90, and it's going to give me 31.2 centimeters. Okay, now here's another way to do that. Let me change color.
I like that way.
Okay, well, this is just as easy, but I'm going to show you that you can't. You should, if you keep it organized, you shouldn't be able to mess it up. Okay? Let's say I chose, instead of doing length and wingspan, I chose toy over actual. I shouldn't say toy, it's probably model, not over actual. Okay, the two categories up here I have now is length and wingspan. Now all it does is it changes the proportion a little bit, but it doesn't change my answer. Because on the toy, the length is x, and the length the wingspan on the toy is 36. So those go on the top. Then on the bottom, the length is 78, the wingspan is 90. If you look,
They're still set up the same.
right, when you cross product, it actually gives me the exact same thing. So just keep it organized, okay? All right, here's another one. See what you can, I'm gonna read it, okay? See what you can do, just on that piece of scrap paper. It says a boxcar on a train has a length of 40. Okay, hold on. Might help if I doodle down some stuff for you since I'm reading them. Okay. Boxcar, length 40. Feet, width is 9 feet. And then it says a scale model is made. So that's the other thing I have is a scale model. And it has a length of 16 inches. And it says find the width. So it has a width of X. Okay? So find X out of that. It does not come out whole, so don't think you've done something wrong if it doesn't work out.
Show me where that mine came out.
No, it doesn't come out whole. Did yours come out whole?
Yeah.
Yeah, then you should be worried.
Okay.
Okay. Should be 3.6.
Mine's
Okay.
6.
All right, you choose, Rachel. Okay? Tell me what you're going to put on the top and what you're going to put on the bottom.
Length and width on the side.
Okay, so you've got length, you got width. Okay, which one did you put first, the boxcar or the scale?
Boxcar.
Okay, boxcar. Okay, so the length of the boxcar is 40, the width of it is 9.
Oh, I put 90. That was my bad.
I could have done it. Okay, all right, so you had it set up right except for that.
Yeah.
I assume then you have 16 over X, like that.
Let me do
Except for the 90.
3.6 is better.
Yeah, there we go.
Yeah, I just put down 90 instead of 9.
Okay, now let me read another type of problem that you might have, and this one we're going to work together because it's set up the same way, but this is one that you will definitely see on the SAT or the ACT. Okay, they're famous for these.
Ooh.
Okay, the ratio of 3 sides of a triangle are 9, 8, 7. That's the ratios, okay? 9, 8, 7. That's not the measurements, that's the ratios. Okay, it says the perimeter is 144. Okay? You with me so far? Okay, you can set this up in various ways, okay? But I'm going to set it up kind of the way that we're doing this stuff, okay? If I added all this together, what would I get? 24. Okay, so essentially if that was my actual triangle, that would be my perimeter of that triangle. Okay, so I could say 9 is to 24 as X is to 144. Okay, and I can solve for the X.
Could you also put 8 over 24? You said to pick one?
Yeah, then I could do the 8, then I could do the 7.
Oh, you have to
Okay,
do all of them?
so I'm going to show you something. It works this way, but there's also an easier way. So I'm going to take 9 times 144, and then I'm going to divide that by 24, and I'm going to get X is equal to 54. Okay, so this one is 54. Then I would do the same thing, but I would do it with the 8.
Oh, okay.
And I would go 8 times 144 divided by 24. That's going to give me 48. You agree? Okay, and then I could do the same thing, 7 times 144 divided by 24 is gonna give me 42, okay? Now, there's another way to do this. They have that kind of ratio or proportion. So whatever I multiply by one would be the same thing I would multiply by the other. So I could turn around and go 9x plus 8x plus 7x equals 24. Okay? So if I turned here, I would go 24x is equal to 24. That's the way that a lot of people go, oh, I can do this problem this way. Does this work?
We get 1, that doesn't work.
It doesn't work. It doesn't get you anywhere. But that is the way that a lot of people set that problem up. You need to do the problem as a proportion. Okay?
Yeah.
And hopefully that made sense to you.
Yeah.
Okay? And just think about this being a little triangle. Okay? And you just, you go, oh, these triangles are proportional to each other, which is what we're about to get into. Okay? All right, so that's that type. Okay, we're gonna move on to not necessarily just triangles, but polygons. Okay, polygons is an enclosed figure that is made up of line segments that doesn't cross over itself. A triangle is a polygon. A square is a polygon. A trapezoid's a rectangle. Those are all polygons. Okay,
A stop sign.
we are gonna talk about similar polygons. Not congruent polygons, but similar. Now, if I have congruent triangles, which we've already talked about, it means everything on this is congruent to this. Okay, so angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. And AB is equal to DE and so forth, right? Congruency. Similar is different. Similar says they have the same shape, but not necessarily the same size. Okay? Twins might be similar. Okay? Identical twins might be congruent. I don't know.
I wonder if
They
their
probably
DNA
wouldn't appreciate you saying
Their
that.
DNA is not the same, is it?
Do what?
They're not like congruent because their DNA is different.
There's nobody that's identical to somebody else. So, okay, so that, would you agree those are both triangles?
They are, and they look.
Okay, now I'm going to tell you that triangle ABC is similar. Okay, so it's like a congruency sign without the equal sign underneath it. To triangle DEF. All right, you with me? To be similar, there must be a congruent angle. So the angles are exactly the same, whether it's congruent or whether it's similar. I can go A is congruent to D. I know that because they're both the first one in my list. B is congruent to E. Allie, you awake? C is congruent to F. Okay, so that's the first thing on similarities. The angles have to have a congruent angle. The second thing is, and this is why we had to do a section on proportion before we did this, the sides are proportional in the same way. I have a limit of 20 minutes on my camera.